Hi everyone, I wanted to show you how to calculate future value in Excel. I'm doing this in Excel. Now, some of you might feel more comfortable using tables that look like this to calculate future value, present value, and payments. I don't particularly like them. If you like them, great, keep using them as long as you know how to do it. I prefer to do it in Excel. So that's what we're going to look at. So our scenario here is that Joseph has $10,000 to put into an investment account and wants to know how much that will be worth in 20 years if he earns an average of 7% interest per year. Okay, so I want to set things up first. So we're going to do one calculation where that interest is compounded yearly and one where it is compounded monthly. So let's start off with yearly first. So the present value is going to be the $10,000 that he has today. The current value, or other words, present value, is 10,000. We're not going to deal with payments in this exercise, so I'll just put that at 0. The interest rate is going to be 7%, so I'll enter that. Compounded yearly. The periodic interest rate. So since we're compounding yearly, it's going to just be 7%. I know that because in order to get the periodic interest rate, I take the annual rate and I divide it by how many periods there are in a year. Since in 1 year there's one yearly period, I divide 7 by 1, and that's just going to give me 7%. The time is, in my example, 20 years. I'll enter that here. The number of compounding periods, again, since it's yearly compounding, I just take the amount of time, I multiply that by the number of periods per year. So again, in this example, since it's yearly, there's 1 period per year, so it'll be 20 times 1, so that just remains 20. Okay, so on to how to use the formula in Excel. The formula I'm looking for is FV for future value. I can pop out a little box here that will help me with the numbers. So first thing I'll enter is the interest rate, which is 7%. What I can do is just click on the cell here that'll enter that 7% number. It shows up as a decimal here on the right. In peer, that means number of periods. The number of periods is going to be 20. I enter that down here, so that'll remain at 20. The payment, okay, we're not really dealing with payments here. I can just enter 0 and move on. The present value we entered at $10,000. And type isn't really going to matter because we're not dealing with payments yet. One thing I do want to do is I want the future value to be a positive number. And the way this formula works is if I enter the present value in as a positive number, it'll give me a negative number. So I'm just going to change the present value to a negative, and that'll spit out a positive number for me. So now that I'm done, I'm going to hit OK. And so it returns my my future value of $10,000 for 20 years at 7% interest. It's going to be $38,696.84. So pretty good for just sitting there for 20 years. Now let's take that same scenario and apply one little twist. So the present value is going to stay the same, 10,000. Again, not dealing with payments yet. We'll get to that later. Interest rate going to be the same at 7%. It's compounded monthly, so it's going to change the periodic interest rate. So compounded monthly just means that the bank sits down once per month, calculates the interest that earned that month, and adds that on there. So what we're going to see here is the value of compounding interest. The way that I get the periodic interest rate, again, is I take the annual rate and I divide it by the number of periods per year. Since it's compounded monthly, that's going to be 12 because there's 12 months in a year. Okay, so the way that I fix this in Excel is I'm just going to tell it, it rounded to the nearest percent. I need to actually bump that out a little bit. So just by clicking out, I can get, it'll show the actual accurate periodic interest rate. So it'll be a little bit over 1/2 of 1%. Time. Okay, so we're doing 20 years. Now the total number of periods in that 20 years, since we're doing monthly, it's going to be the 20 years, again, multiplied by how many periods there are in 1 year, which is 12. So it's going to be 20 multiplied by 12 returns 240. So now I'm going to do the future value formula again. Equals FV, open up parentheses. Again, if you want to, I can pop out this worksheet that some people find helps them. So the rate is going to be the periodic rate. I'm going to find that here, periodic interest rate. Number of periods, it's going to be the 240 that we calculated. Payment, again, we're not doing payments right now, so I just leave that as 0. Present value at 10,000. Put that there. Again, we're not worried about type right now. We'll get to that later with payments. So I hit OK. Well, you see what I did there is I forgot to make the present value negative. So you live and learn. Okay, now that we've fixed it. So it returns a future value of $40,387.39. You can see that's a little bit more than the future value when we compounded yearly. And that's because for each month I earn interest. Then the next month it earns interest on the interest that I earned the month before that. And so over a long period of time, that compounding can actually add up to some pretty significant numbers. So that's how to calculate future value of a lump sum in Excel.